Welcome you all. In this class, we have a question. For all set A, B, C, there is A union with B intersection C and A union B intersection A union C. So we have to prove this statement. For this is the proof we need to do, and in graph, if you draw in Venn diagram, where this type of diagram will form, which is equal to the both one. So going to proof of this, let's suppose first of all x belong to the given set and the given solution A union B intersection C. Now by the definition of union, we can say that x is belong to A also, or there is or by the definition, and or x is belong to B intersection C. Now we can consider that either x is belong to A. For first case, x is belong to A, so we can say that since x is in A, then we have x belong to A union B by the definition of union. Next also x belong to A union C by the definition of union. So finally we can say that x belong to A union B intersection A union C by the definition of intersection. Then we have next case also. In this case, we can say that x belong to B union C. So by the definition of intersection, we say that x belong to B and x belong to C. Okay. Now, since x belong to B, we can say that x belong to A union B. This is the by the definition of union. And also x belong to C, so x belong to A union C also. This is by the definition of union. Now by combining this, x belong to A union B and intersection A union C. This is the by the definition of intersection. So finally we can say that by combining both case, we have x belongs to A union B intersection A union C. So from the both case, we have A union B intersection C is subset of A union B intersection A union C by the definition of subset. Okay, next we have to prove in other side also, so that we can say this is a equal set. Okay, now in this case, suppose x belong to A union B intersection A union C. Now for this, by the definition of intersection, we can say that x belong to A union B and also x belong to B union C. So here also we consider two cases, either x belongs to A or x does not belong to A. Okay, now first case, x belong to A, we have x belong to A, then x belong to A or x belong to B intersection C. We can say that. Now for by the definition of union and intersection, we can directly say that x belong to A union B intersection C. Okay, so from first case we have this equation on this condition. Now for the second case, we have x does not belong to A. For this, x is in A union B, so that x is at least in one, like A or B, there must be, because of union, so there must be in A or can be in B. Now we are saying that x is not belong to A, so x must be in B. So similarly, we have x belong to either A union C, so x at least can be A or C, but we are saying that x is not in A, so x must be in C only. Okay, next moving, hence x belong to B and x belong to C. So from this relation, we can say that by the definition of intersection, x belong to B intersection C. Now by combining these two cases, we can have x belong to A union B intersection C. This is the by definition of union. Okay. Now, from two condition, we said that two cases. A union B intersection B union C is subset of A union B intersection C by the definition of subset also. At last we have the both, like the both is a subset of both ones respectively. So at last we say that A union B intersection C is equal to A union B intersections to A union C. Okay, and in this Venn diagram also we proved it. Okay, thank you all. See you next class.